This is video-journal-752c06f532f1. My name is Eric, and this is installation 0E90-743c7961. Indeed, it's a bootable USB. To be specific, it is a 1 terabyte fully encrypted bootable USB, capable of running on a variety of different systems and able to create not only copies of itself, but basically any other machine you could imagine. Today I'm going to show you how it works and what I intend to do with it. And we're going to kick things off with a somewhat unusual use case for it, that is booting it as a virtual machine. Now, like I said, this is not my general workflow with the USB, but it's the best way for me to show it at the moment. So into VirtualBox we will go. As you can see, since this is a fully encrypted operating system, we need to give it a password to decrypt right out the gate. So I'll do that. And since this is running in VirtualBox, it will take a minute to decrypt, which gives me an opportunity to let you know that if you are interested in following up on this project, you can learn more about it at eom.dev. And if you'd like to look at any of the source code that I have written for this project, you can find that at git.eom.dev. That is git.eom.dev. Additionally, I just want to point out that since we are running this in VirtualBox, there are some graphical limitations. The USB is actually a command line only machine. Even so, though, the resolution provided here by VirtualBox is very small. So it's not going to, it doesn't look like this when I usually use it. It doesn't make a difference for what I'm trying to show you here, but just know that going in, that when I'm actually using this machine, it doesn't look quite as small. Anyway, in a moment here, we will be able to log in, and I will show you that I am very committed to my naming schema. The names for this video and the installation and the user are all arbitrary. They are generated IDs so that I can easily identify things on the network that I am building. It will make more sense as we go on, but just know that that is the reasoning behind the crazy names. Anyway, here we go. We are user. It's a secure password. Beautiful. So we are logged in, and you can see that there are a few things happening right out the gate that have to do with my user environment. We're going to ignore those for the time being and come back to those in a little bit. And the very first thing I want to do is show you how this USB is formatted. So we're going to do lsblk, and to accommodate for the small screen size, we're going to pipe that into less-s. And here we can see the partition schema for this drive. It is SDA is the drive in question, and we can see right out the gate that it is partitioned into 4 sections: SDA 1, 2, 3, and 4. SDAs 1 and 2 are our bootable partitions. This contains a BIOS boot and an EFI partition. The difference is basically for legacy versus newer machines, what they do to boot up. This USB supports both systems, so regardless of which type of system you are trying to boot on, this one will work. And these are actually the only 2 totally unencrypted partitions on the machine. The reason being is that when you want to boot the machine, it needs something unencrypted to load, the initial RAM disk. So that exists on these 2 unencrypted partitions, and contained in that is the information needed to decrypt the rest. Okay, so those are our 2 booting partitions. The other 2, SDA 3 and SDA 4, contain our data partitions. You can see that both of those are first blocked off into a LUKS container, and this is the encryption layer for the USB. So the LUKS container basically will contain partitions that will have encrypted data in them, and the LUKS container will handle encrypting what's going in and decrypting what's coming out. So we have the LUKS container, and then we have what is called LVM. So these are logical volumes, makes it a little easier to resize things, but that's the basic layout of it. It is a LVM on top of a LUKS container. And like I said, SDA3 is for the operating system itself. This is where Arch Linux and all of its applications will live. And SDA4 is for data files, somewhat personal data files. So, for example, if I were to plug this USB into a different computer, say some other Linux computer, and I just wanted to access my repositories, which you can see are mounted here, I could just decrypt SDA4 and I would get access to all of my data files there, with the exception of the last one, which, as you can see, contains another Luke's container. This is for a vault, and it contains password files, things like that, and it makes it so that I don't necessarily have to decrypt the vault files if I do decrypt the final partition as I described. Anyway, this partition doesn't contain just personal files. As you can see, not everything is mounted to my home directory. We also have ref and source, and those are very important to this USB, but we are going to come back to those in a little bit. And instead, I want to show you how this machine is kind of put together first. So what we're going to do is go to Etsy. So with any Arch Linux installation, there is a basic schema to how they work. So you format your hard drive, you install your applications, and then you write your configurations. And your configurations live in Etsy. And just like all Arch Linux installations, that is the case here as well. But you may notice that there is something a little bit different about these. It is that they have a lot of soft links. So if I do ls-l instead, pipe that into, pipe that into less. And you can see that we have, for example, crypt tab is pointing to user local source, installation 0e9e, and EOM and FS tab. Those are all pointing to user local source. And the reason is that the installation itself is totally source controlled. If we go to user local source, there's a repository here, a Git repository, that contains all of the information needed to put this machine together. So if we look in here, we have an Etsy folder, and all of those links point to the files that exist in this folder. That way the configuration for the machine is entirely source controlled. So if I need to create another one of these, all of this information is right here, and I can very easily just put all my configurations back in place, and I'll be up and running again. Additionally, we have automated install scripts to do this for me. So if something should happen to this USB, and it will, we'll get to that in a bit, I can very easily recreate it by running these scripts using the things that are defined here. So that is the basic format of this. We have a few partitions on the USB, and then we use soft links and source control in order to define the actual configuration of this machine. And that is what I mean when I say that it is able to create copies of itself. If I were to plug in another USB, format it similar to this, and run my install scripts, it would create a brand new copy of it. But it can also create copies, or rather, not even copies, entirely new machines. Watch the mic. So yes, we can create entirely new machines that have nothing to do with this one. And that is because of the partitions that I was mentioning earlier, source and ref. So if we go to ref, what we can see here, at the moment, it only contains one file, or a few files, including a lost and found, which should be deleted. We'll do that now. That is a useless feature, creating lost and found. Anyway, we have a copy of the entire Wikipedia database. So any Wikipedia article that we might want to reference is available here locally. So we don't need the internet for any of the information that may exist on Wikipedia. It also contains the man pages and Arch Wiki Lite. So we can do, let's just look for QEMU. And so we can search for packages, and it's not showing up. There we go. So we can actually search the Arch Wiki as well. So in addition to the repository of how to build it, it contains reference guides on what to do in order to build it, the instruction manual. Beyond that, in source, this is the big one. this contains a complete mirror of the Arch Linux repositories. So all of the packages that are available in community, core, multilib, extra, let's see. Anything available in any of those repositories, I have a local copy of here on the USB. If we look at my mirror list for Pacman, we can see that it only has one server, and it's this local file. So if I want to create a copy of this, it actually already contains all of the repositories for applications that I could need. And even if it's not a copy of this machine, it has the repositories for applications that I could use for any machine that I could want, or that you could want. So this is like the Arch ISO on steroids. It is fully self-contained for information and sources, and it's able to build the machines the same way that the Arch ISO is. Okay, this goes a little bit further though. If we go to my home directory and look at these repositories, so here's the original, the source for installation 0E9E. We can see that this got copied over to user local source as part of the install process. But this, if we look at the git log, all of the log statements mention its name, except here. Okay, we can see origin master, origin head, is installation 000. So what's happening here are cascading templates. The idea is that I may want to create very, very many different types of Arch Linux installations. So I don't want to have to recreate all of the same files every single time. I would rather have a single template that is installation 000 that I can just copy as many times as I want and only change the specific files. So if we go back, whoops, we can see a lot of those same files, in fact maybe all of them, are present in installation 000 as well. But it's just a bit more generic. If we look at the packages here, OpenSSH is the only one listed, versus in installation 0E9E, we still have OpenSSH. We have all of these other applications that are installed as well. And what I did was clone installation 000 into installation 0E9E, and then just edit the files a little bit further to get the rest of the installation. The idea here is that I will be able to very quickly create a lot of different types of machines. If we actually go back a layer, installation 00 is also a clone of, whoops, installation template. So installation template is meant for anybody who wants an automated Arch Linux installation, can clone this template, and it should work for anybody. It is that generic. It is a little bit buggy though, so at the moment it's active development. So if you choose to use it, it's available, you can learn from it. It's still being developed at the moment though. Anyway, so the installation template becomes installation 00, becomes installation 0E9E. So we have one that's suitable for everyone, one that's suitable for my network, and then a very specific machine on the network. And if we go back, you can see that I've already begun creating additional machines, and we will talk about those in the future. So we have machines under source control, but we also have users, groups, and policies under source control as well. If we go back to just the repositories, we're going to list what's in here. Ignore the blockchain, that's coming later. We have groups, installations, policies, and users. Let's go to the users because that's the most fleshed out at this point. You'll see that it has basically the same structure. We have a template, we have user 00, and then we have some more specific users. And it's the same idea. I may want a variety of different users. All of them are almost the same except for one or two attributes. So we create this cascading set of Git repositories that can be cloned into different templates and into specific machines. One of the benefits of this is that if I want to change something that affects many users or many installations, I can just edit the template and then pull those changes into all of the other machines as well. Let's take a look at this current user, for example. So here we can see we have profile, and here are all the profiles. So if I list my home directory, you can see that all of those are present here. And again, we have soft links to the actual user local source version of this. Oh, but I said user local source, not my repositories. That's because users, policies, and groups are added as submodules to installations. So if we look in our installation folder, we have users, groups, and policies. So an installation can contain users, groups, and policies. A group can contain users and policies, and a user can contain policies. So a group may contain a few different users, and it may have rules that apply to all of those users. That's a policy. And a user may have several different rules that apply to them. That's a policy. Or the installation may have rules applied to it, and et cetera, et cetera. You can basically put these within one another in order to create the specific machine that you want. It's a little easier to see in the example. So here, again, we're in installation 0E9E. We can see that the users that it has are just this current user, E94C. And this is added as a Git submodule to installation 0E9E. If we look in the users, we see there's a policy in the user. Okay, let's check out policy 7. And we'll cat the README. Okay, so this one will basically set whoever user is, or for whichever user contains this policy as a submodule, that user will be added to these groups. And that's all automated through this installation script. So I hope you can see what is going on here, that by abstracting users, groups, policies, and installations into their own set of templates and Git repositories, and by cloning those templates into more specific versions of themselves and including them as submodules in other repositories, we are getting a library of all of these different tools so that you can create a variety of different machines with a variety of different users, all from this one USB. And again, since it contains all of the repositories for applications locally and all of the references for how to use those applications locally, this is a one-stop shop for basically any kind of computer that you could need. It has a few limitations though, mainly being on a USB. A USB has a finite lifespan, so a finite number of read-write cycles. And at some point, this one's going to break. So I do need to keep an active backup of it and make sure that I am at any time ready for it to fail and to move over to another, which is a bit of a pain. And given that this is a 1 terabyte USB, that can get kind of expensive. So far, I haven't had any problems with it, but we'll see how long the actual lifespan ends up being. So, what do I plan to do with this crazy thing? Well, it is going to be the primary node of a network of virtual machines. You might be able to see right behind me, I have a server there, and with it, actually, let's go back to the installations repository. You can see installation 000, that is the template that I used to create 0E9E, but you can also see installation 0001, and that is a separate template. That is going to be a template for hypervisors. That is a operating system intended to run other virtual machines. And I'm going to be installing one of those on that server as well as another machine that I have to start building a network of all of these different virtual machines that I will be cloning from these templates. And later, as I indicated, we will be using a blockchain on these hypervisors to actually get them to coordinate their actions together. So that is for the future of this project and this USB. If you're interested in seeing me continue that along, eom.dev is the place to go, and git.eom.dev is the place to see the repositories and source code for yourself. So I believe that is all that I had intended to share with you today. I will give you an update as soon as I use this USB to create some hypervisors for that machine there and another one that you cannot see at the moment. So I hope you will join me for that video. And until then, thank you for joining me. Toodaloo.